So let's talk about Newman projections. So a Newman projection is just a different way to look at a molecule. So in a Newman projection, you're looking down the C-C bond. So there's 3 steps that you want to go through to convert a line angle formula into a Newman. So what I would say is first you're going to identify the 3 groups connected to the front carbon. And you're also going to want to take note of their orientation in space. So is it on a wedge, is it on a dash, is it straight? Because that's going to be really important. So I'll just say take note of location in space. Then for the second step, you're just going to do the same thing but for the back carbon. So you'll identify the 3 groups connected to the back carbon. And then again, you'll want to take note of their location in space. And then finally, you'll just put the pieces together. So it sounds simple, and it's not overly complicated. It's just tricky the first couple times to really kind of visualize, how the substituents are arranged in space. So let's say we have this guy. That's a bromine. Okay, and actually let me just add another little note down here. So we've got there's the 2 different types of, we can either have a wedge or a dash to indicate the stereochemistry to locate if the substituent is coming out of the page or coming out of the page or going into the page. So the wedge is coming out of the board. And the dash is going into the board. And another way you can think of that is if I'm imagine this is me looking straight on at a molecule right in front of me. My right arm is coming out. This is like the wedge, and my left arm is my right arm is the wedge. My left arm is the dash. That's going into the board, and then anything that's just on a straight line is just in the plane. It's not coming out, it doesn't have any 3D. So, if I'm looking right here, and supposed to draw a Newman like this, well, so something that you might find helpful is instead of just drawing this eye, which is typically what happens, you can draw is the whole observer. So there you've got so that's me looking at the board. So yeah, that's me looking down. Imagine I've got this molecule right in front of me. So you've got my left arm on the dash and my right arm on the wedge, and I'm looking straight at the board. So right arm coming out, left arm going in. So let's look at the front carbon. And let me also draw in the hydrogens that are excluded. So before we talk about the location in space, we'll just identify what's attached. So we have bromine, hydrogen, and a CH3. And in the back, we have a chlorine, a hydrogen, and ethyl. So I'll just abbreviate that ET. Okay, so now let's go and figure out how this looks and find the orientation. So the bromine, it is on a wedge, so that's my right arm, so it's coming out of the board, and it's going to be on the right. The hydrogen, just the opposite, it's going into the board and it's on the left. And then this CH3 group, well, that's just straight down. That's because I've got my bromine coming out to the right, my hydrogen to the left, and then just straight down, there's the bromine, or I'm sorry, there's the CH3. All right, so we can even draw what we have so far. Okay, so that's what we're looking at from the front carbon. And then for the back carbon, well, the chlorine is going into the board and on the left.